What's up, guys? Let's take a look at another CodeWars exercise. This one's called Pokemon Damage Calculator. When one Pokemon attacks another, you might take into account base damage, stats, and most importantly, the relation between the types. Fire does more damage against grass, but less against water, that kind of thing. So let's say this is our formula, which is probably not the same formula from the games, but it's close. And these are our types. They only ask us to handle 4, which is great because if we had as many as the games do with Dragon and Bug and Ghost and Magic, there would be hundreds of combinations. They give us the ones that are strong against another, the ones that are weak against another, and the ones that are neutral, like Charmander versus Pikachu. Neither has the advantage. And then, most important, or the most missable, is this line right here that says any type against itself is not very effective. So if I'm grass against grass, I do less damage. Then we get a function that takes these things, spits out an answer. I'm going to look at 2 solutions first. This is one that we're trying not to do. We're trying not to be like this, whose name I'm hiding because I don't want to pick on anybody. But if, elif, listing all the combos, this has a few problems. 1, it doesn't even fit on the screen, so I can't see it all at once. 2, there's a high chance of mistakes if I'm copy-pasting and changing things. Very high chance I mess up. And finally, it would be annoying to change if someone comes up, your boss says, all right, Johnson, we're going to add 3 more types in the sequel, and they got to handle normal and psychic and whatever. Then you have to add all of those in here, all of those in here, all of those in here, and it would really explode the amount of lines. So let's try to do something else. Let's try to separate the data and the logic, all the info about what beats what, from the little formula, which ideally is just a single line. Here's one that I did, and this is another thing we're going to try to avoid, because even though this works, I tried to cheat and I just said, let's just take the first letter of each one, which is kind of readable. If you see FG, you can probably guess that that's firegrass, but other ones maybe not. WE, I'd have to think. And just like the last one, this would be a mess if we tried to change it. If our boss said, what about ground Pokemon? You've got to handle ground. Well, I can't do that in here because I've already got G for the grass. I can't use capital G because then what if we get a different string? I can't use GR because that's still ambiguous with ground and grass. And I'd have to throw this out and start over. So let's try a different setup that is readable, hopefully short, and most of all, changeable. So let's give it a shot. They have 4 things: your type, opponent, attack, and defense. And most of those are easy to get into, so let's say return 50, which is like the base damage, I guess, a standard attack. And then attack, defense, which we can just use straight up as they come to us. We don't need to do any formulating, processing, rounding, or anything like that. And then finally, the interesting part is times effectiveness, which is going to take into account and be a function of these other things. Okay, I'd love to have only this line in the function because it matches our formula. If someone was reading the code, they would know what's going on. And it makes it so that the effectiveness is separate. Maybe you'd have other parts of the code using that. Maybe you have AI that decides whether to run away and not do a battle. Maybe it looks to see if they're weak against the other type or something like that. And we couldn't use that if it was buried inside the calculate damage function, but we could if it was its own thing. So let's say there's going to be a function called effectiveness, and it takes 2 types. We don't need the same names here, and I don't really like those names, so I'm just going to say element and other. It's a classic thing in Python. If you're comparing, you call the first one whatever it is, and the next one other. And I didn't want to say Pokemon because this is not taking a whole Pokemon with stats and name and whatever. It's just fire, just grass, you know. And then it'll return a number like our multiplier, 2, 1, half, that kind of thing. But still, I'd rather keep the data a little bit separate, so I'm going to make a piece of, I don't know, list, dictionary, something that this can look up, or maybe this can look up, or anybody can look up when it needs. This is like the projects we've been doing where we look up data on students from a file, and then our functions can take it, but they don't embed that inside the function. The function is not like, if the student ID is 301542, return this student. If the student ID is something else, return this student. They just say, look at the data, figure it out. So let's say, what have they given us here? They've given us a mix of some greater, some less, and some equal, and our job is to arrange them all the same direction. I'd love to have all less than or all greater than, so that we can say, we look this up and it's moving through. We don't have to say like if, all the same stuff. It's just moving right through the process in one direction. Even though the less thans are more common, I'd like to go the other way. I'd like to say what beats what. So let's flip them. So let's do this. I'm going to keep this. I'm going to flip these. I'm going to delete that because I don't need the equals. The equals will just be the other, the else, the otherwise, where nothing happens. They're just the same. I'm going to switch these, so grass beats water. And I'm going to switch these, so electric beats water. And then I'm going to delete this. Okay. Now, what do we do with these? Are we going to put them in tuples or lists or dictionary? I'm going to just do tuples for the moment, and then we'll see how we might look them up. Let's say we have a choice to put the numbers in here. We could say like, oh, if you're fire grass, then that's a 2. That's your multiplier. Or we could keep them out and put them in here. The balance might change, right? Games have a patch where they say, oh, you know, when you're strong, we're going to change it to do 1.8 times instead of 2 times. So we could put that elsewhere. It's not a big deal. I'm going to do just these. Okay, I'm going to call this strong. Did I hit caps lock? And strong will be the relationships of what beats what. So like fire is strong against grass, water is strong against fire. And my goal is, that's it. I don't have any weak, what doesn't beat what, because I can just flip these. I don't have any what's equal, because I can just say else. And that's all I have to list. If I get more types in the future, like dragon, ghost, whatever, I can add 1 or maybe 2 lines in here to say what does it beat. That's it. Okay. So let's say, okay, if element other is in that list, is in strong, 2, because we are doubly effective. Okay. If they are strong against us, so I didn't rewrite this whole database with twice the stuff. I just said, oh, what if you flip them? What if they beat us? Then we return 2. Now, ideally, or theoretically, those could be different, right? There could be somebody who does double against me, but I don't do half against them. I'm pretty sure it always is the case, and I'm definitely sure it is in this example. And then else return 1. So if we beat them, double. If they beat us, wait a minute, half, and otherwise 1, which means times 1, which means no effect. So let's try that. I hit the button that says test, and it says, wait a minute, I forgot my commas. Now it says passed, but come on, we didn't really pass everything. If I hit the button that says attempt and do the big ones, I will fail some because I know I missed one line that I pointed out at the beginning. This says I failed a bunch. So let's say we're not sure. We're going to scroll down and look for a pattern. Sometimes you'll see a pattern in your failed tests, like you're always too low, or you're always too high, or you're always failing when we should have recognized an error, or something like that. So look at that. We're double, we're double, we're double, we're double. So the pattern we're seeing is that something is doubling when it shouldn't, or staying the same when it should be halved. And I know, because I pointed this out, I just did it in class an hour ago, but if you remember, this line was in there. It said, we're, the idiom about fighting fire with fire is not accurate here, because fighting fire with fire is the worst thing you can do. You're weak. In this case, any type against itself does half. So we could add that in here. For example, if element equals other, return 0.5. We could add it in here as like if this or element equals other, but we don't have to add it in here. And it would really be a bad idea to try to add those in this data, because then it would matter which order you check these. Like right now, these ifs could be rearranged in any order and it's fine. But if we put the equals in there, then it's like, well, we better hope that we check being weak against them before them being weak against us or something. That would be a nightmare. So if I hit attempt, or let's hit test, because sometimes you add something and it ruins the part that was working initially. So hitting test makes sure that I didn't ruin that. And now hitting attempt says, okay, I got it. Let's go ahead and submit this, even though it's different from my other answer. You can always submit more than one in CodeWars. And let's see what some other people have done. This guy says import math. I wonder what he's going to do with that. And then we've got these effectiveness little dictionaries. They look a lot like JSON. If you get data from a website or an app or something, it's usually encoded in JavaScript object notation, which looks like this. And hey, it's a little bit verbose. It uses a lot of repetition so that every single one lists its relation to electric, every single one lists its relation to fire. But it also means that if I look up electric, then I get everything I need. If I look up fire, I get everything I need. And there are benefits to that, even though it's bigger. You know, it would be a little annoying to change when your boss says we're adding a new type and you have to add it in here and here and here and here. Yeah, admittedly. But it's better than a bunch of if-else, because they keep the data separate and then the logic is one beautiful, crisp line. Now this says math.steal, so maybe, I didn't do anything with rounding. Maybe an older version of the problem said that you have to round and then they took it off. If you look at CodeWars, some questions have been around for a long time and they have gone through a few versions. But this one's great. I'm going to give him an upvote. Why not? This one does a much shorter version of the relationships by just saying what beats what, kind of like ours. And so if we beat them, okay, and then this if-else stuff is just the same as well, I don't have mine up anymore, but it's the same as mine where it was like if we're strong, if they're strong against us, whatever. This one is pretty cool because they use a matrix, which is 2D combos. If we take our type in the rows and their type in the columns and we just find where they match, that's pretty cool, and that's how a lot of bigger machine learning and AI things work is they just have a giant matrix, or really it's called a tensor because it's more than 2 dimensions. All of the factors go into finding some point, and that's pretty cool. If it was a lot, it'd be hard to read. You know, if we had a Generation 9 Pokemon game, it would be 20 by 20 or something. But of course it'd be in a separate file. You don't actually have to look at it when you're writing the code. And again, they end with this nice, crisp, expressive formula. That's great. So if you look down, you'll see quite a nice variety. Some people are looping through a list or a tuple or a dictionary. Some people have multiple functions. Some people have the data really far out. Some people have the numbers with the data or the numbers with the function. And it's wonderful to see that variety. Even though this is a simple problem and you could do it with nothing but if else, it shows the approaches and styles that are out there. And I would really say going through the solutions is more educational than writing the code yourself. Thanks.